All right, today is the 4th of March. So 3/4, let's write it down. Today's the 4th of March. We are in Algebra 2, Lesson 6-8, Nested Fractions. These are pretty straightforward. They're one of the easier parts of our unit. Two things to remember. First, if I have something divided by something else, I chose to do a square and a circle. It doesn't really matter. I could have done a square and a triangle. That's really just saying that they're dividing. So if I have like 3x minus 5 and 4x plus 5 or something on the bottom, you're really just dividing. This is really just square divided by circle. Easy peasy, right? Just another way of doing division. And then what was our cool little jingle for dividing fractions? Keep it. There it is. Write it down. Keep it, change it, flip it. Notice that this rule goes with nested fractions, but it also goes with fractions that are just being divided. For example, if I had a fraction divided by a fraction, I would still do keep it, change it, flip it, but I'm going to be writing them like this. I'm going to be writing them in what's called a nested fraction. Let's see our first nested fraction in example 1. All right, I need to find an equivalent form for this guy. So equivalent form on Khan Academy is going to be multiple choice, and you're going to have to match it with something else. But generally speaking, there's only one way to solve these, and that is to keep it, change it, flip it, essentially. So we're going to go ahead and multiply these out. So if I keep it, change it, flip it, I'm going to write this down as what? Who can read this to me? Quiet raised hand. Stego.
Oh, I don't want to write it. Can I tell you though?
Yeah, you can tell me and I'll take your card.
Oh, that's it. I thought you were giving me the pen. I was like...
Give her the pen. All right, this is going to be equal to what? X divided by y plus 1. All of this times... that's the troubling part, right? But you're right. You're thinking about trying to flip all of this bottom fraction, right? So the only way that we can flip it for now is by doing 1 over whatever this fraction was. So if I flip it, this used to be over 1. So if I flip it, now 1's on the top. The bottom is going to be plus 1. Yep. And you'll notice that that still doesn't really get rid of our fraction problem. So what we're going to have to do before we do that is turn both of these into fractions. So right now I have like a fraction with a number. I want this whole thing as a fraction, and that's actually the strategy that I'm going to make you write down in a sec. The strategy is to make sure your numerator and denominator start off as fractions. So I guess we'll just go ahead and give this a giant cross out. We're still not going, you can erase it if you want, but I like leaving it there. We're really going to be multiplying by something else when we turn both of these into fractions. So let me come back down here. If I were to combine like terms, I can't add these two because they don't have the common denominator. This is something over y, this is not over y. So how can I turn 1 to something over y? Anyone have an idea? How can I add this x over y with 1 to make one fraction? Multiply 1 by y? Close. Multiply by y over, not y over x, not y over 1. You're only allowed to multiply by 1 whenever you multiply by fractions. Say again? There it is, yeah, y over y. What I'm going to do to this one is I'm going to multiply by y over y. By doing that, that gives me, oh, can't aim. Okay, so that gives me x over y plus y over y. I have a common denominator. I can actually add the top. The top now, and I should switch colors here. The top now is x plus y. This is now x plus y for the top. The bottom now is y. This was the top fraction. It does now turn into x plus y over y. So if you're adding, the denominator just stays the same. Yeah, you don't add them. So I kept it. I mean, I had to rewrite it, but I kept it. I'm going to change it to a multiply. It used to be a divide, and I'm going to flip it. So this is going to be a lot of mental work, but let's go ahead and try to convert this fraction, this y over x plus 1, into something over x. So 1. What am I going to multiply 1 by? Shout it out. I heard two people say it. Say it again. X over x. If I do that, x over x is the same thing as 1. What's y plus x over x plus x? This fraction turns into, quiet raised hand. We'll give it for a card. Try to get a card in. Gio, you want to do it?
Y plus x over x.
There it is, y plus x over x. So that is the same thing as y over x plus 1. It is the same expression, just rewritten in a different form. Now that we have it rewritten in a different form, I'm going to use Stego's keep it, change it, flip it. I kept my top. I flipped my sign, or I changed my sign to from a division to a multiply, and now I'm going to flip this guy. So it's going to be x on the top, and on the bottom I'm going to have y plus x. By the way, y plus x is the same thing as x plus y, so I'm actually going to write x plus y. So far, so good? Yeah, man. All right, so from here, I can cancel things out. Does anyone see something on the same on the top and the bottom? Yeah, Eva, what do you see? So what should I do with them? Cross them out, yeah. And I have my final answer.
Oh, that's just for that.
Yeah, thank you, Eva. I'll take your card. Got to collect them. All right, so the general strategy, we'll write it again, is to make sure that the numerator and denominator are fractions. So turn, I'll abbreviate here, numerator, I'm just going to say NUM, and denominator, DEN. If you don't like numerator and denominator and you want to write top and bottom, I'm fine with that. Turn top and bottom into fractions. Before you do the keep it, change it, flip it. Before keep it, change it, flip it. If you follow that one hint, that one strategy, it'll make all of these problems much, much easier. Okay. Well, let's use that strategy. Someone that hasn't participated yet. What am I going to do? What am I going to do? He arrives. Yeah, Andrea, go for it. Say it one more time. All right, this 2 is going to be x over x. And when I do that, I'm going to get 2x over x. And then how do I add that? 2x over x plus 2 over x is, I guess I can go to the right. It doesn't, I don't know, I'm going to the left. 2x plus 2 over x.
Wait, I don't get where you're dividing whatever the x over x.
That's dope.
Why are we multiplying by x over x? Is that the question? So we need to turn the numerator and denominator into fractions. Right now we have a fraction with a non-fraction. We want this all as one fraction. But I can't add 2 over x plus 2 because 2 does not have the denominator x. We have to have common denominators. So in order to get common denominators, we can multiply by x over x. I don't know why that happened. We can multiply by x over x, and therefore our denominator is now x. We have common denominators. So when I do that, Andrea, can you help me out? When I add these two fractions, what do I get? 2x plus 2 all over x. Perfect. We have the numerator. Done. Now we're going to do the denominator. We're going to do this bottom part. We need to turn this bottom into one fraction. But I can't do that, unfortunately, because this is divided by x. This one doesn't have an x. I need to have like denominators. What am I going to do? I need to call on people that haven't participated yet. I'm looking at James and Teflon. Teflon, go for it.
Is it the same as the top?
What do you mean the same as the top?
Like multiply by x
Multiply just by x?
over x.
Over x, okay. When I do that, what is it going to become? What is my new fraction? 3x plus 3 all over x. Yeah, it is. Thank you. All right. We have used our strategy. We have turned the top and bottom, the numerator and denominator, into one giant fraction. All right, now we can do the keep it, change it, flip it. So let's do that. Keep it, 2x plus 2 over x. 2x plus 2 over x. I kept it. I'm going to change it. It was a division symbol. Now it's a multiply symbol. And finally, flip it. It was 3x plus 3 over x. Now it's x over 3x plus 3. X over 3x plus 3. What should we do now? I need a quiet raised hand. What should we do now? Lots of people, lots of people. James, you know what to do? No? All right, Gio.
You cross out the x.
Cross off the x's. We have the same thing on the top and the bottom, and I'm left with a new fraction, which looks like 2x plus 2, all divided by 3x plus 3. We're not done. It might look like we're done, but we're not. See if someone can find the next step. Ooh, yeah, Eva, go for it. It's a good idea, and it doesn't quite, because we can only cross off things that are being multiplied, right? So we can only cross off when everything is being multiplied. Right now, 2x is being added to 2, so we can't just cross off the x and the x, for example. You're thinking like that and that. So you can't quite do that because, I mean, it mathematically happens to work out that way, but it normally does not work out that way. Huh, weird. Stego.
Do you simplify or like factor whatever it's called?
Yeah, so,
Take 2.
all right. So tell me what to write.
2 parentheses x.
X plus 1, and on the bottom?
3 parentheses x.
There it is. We factor. Perfect. Thank you, Stego. And you need to keep track of these. And then from here, finally, the last step. James, you want to try it? All right, Fiona. Cross out the x plus 1s, and you're left with a final answer of 2/3. Final answer is 2/3. All right, yeah, that's it. We know our strategy. We've seen 2 examples. Any questions? All right, that's it. Go ahead and write your summaries. Homework's on Khan Academy.